Hello and welcome back to another episode of the Oxford MAT Livestream. My name's James. I'm the Admissions and Outreach Coordinator for Maths at Oxford. Talking slightly too fast there. And today we're going to look at graphs and transformations. Great to have you with us. Great to see you all this evening. Let me just set this up so that it's the right way up. I think again Slido has very slightly changed, so I have a scroll bar has appeared. I don't know what that's for. Right? I think if somebody asks a very, very wide question, then look, I can. If it goes over there, I don't know how that's. I don't know why that's happened. Right. Computers. What are they like? I think I've remembered to go live. I think I've remembered to unmute myself. So those are things I might get wrong. Hello to Aaron and Jacob and Kay and Anonymous in chat as well. I've met several people on the open days over the last couple of days, and some people tell me that they've found the Maths Club or found the Math Livestream. Several of the people I've met have told me that they are anonymous in chat. So nice to put some faces to the anonymous. Right, and there's a question. Hello, two more anonymous people in Mania. Hello, good to see you all. For long response questions, what's this? Long response questions involving logical. Right, hang on. I'm going to highlight it. I'm going to scroll down and highlight it. For long response, no, that's Arab. Where's it gone? There it is. For long response questions involving logical reasoning in math past papers, are there any alternative answers? Yes, probably. There's probably multiple ways to do these questions. Apart from mark scheme that examiners will accept. Yeah. So you haven't seen the mark scheme. You've seen the web solutions. The web solutions is a document with at least one way to do the questions. But the marking scheme gives instructions to markers to award credit in other situations. And the reason I use graduate students to mark the math is that we can identify other situations as we're going along. We don't release the detailed, boring mark schemes. Jacob was here, there you go. Wasn't visiting the maths department? Fair enough. Right, but you are here for the Matt Livestream. Well, there you go. Well, let's see. And shout out to Callie, 2 L's and a Y. Callie, C-A-L-L-Y, who is moderating chat. I am letting you know how to spell Callie, C-A-L-L-Y, in case you want to say hello to Callie in chat as well. Few maths books from years ago. Lots of this maths has not changed over the years, so I think you might be okay. Let's put on the How Was Your Day poll. Let's go for that. This is a way for people to vote for how their day was on a scale from 1 to 5. Let's find out, has the scroll bar put any more options in? Nope, nothing over there. Just more greyness over there. I don't. Today, Slido has given me some extra panel to scroll to with no content, so I'm going to be perpetually distracted by that. Oh, and this is A, he says, first time watching live, I've had to catch up on the others. Well, hello, welcome up to speed. I've just noticed that my printer has done something really strange. So it's printed everything it's gone single-sided halfway through. It's just it started improvising halfway through my copy of the document, which is Graphs and Transformations, a collection of revision notes. Let's have a look at it while chat is voting away. Let's have a look at what's going on. So chat's going to be kind of on top here, isn't it? Never mind. Okay, so this document has a bit of math syllabus at the top. It has some revision notes. It has some more revision notes. It has more revision notes. It has some revision questions, which are designed to maybe bridge the gap between A-level and maths. We have about 15 of those to choose from today, and then some math questions, which hopefully we get onto you talking about some math questions later on. But we're going to start up here. I think if you'd like this document, if you'd like to play along or get ahead, then on the Matt Live website, which is on screen just here and is in the YouTube description, and to be honest, if you search for Matt Livestream, then I hope you find it. That webpage has got all of the worksheets for these first 8 episodes that we're doing. This is the 4th one, looking at different topics on the Matt syllabus. That's the plan of what we're going to do. You could get ahead. You could look at the solutions on the web. I've been telling people on the open days that they can join in with the live streams if they like, but if they don't want to watch YouTube videos, then they can just do the worksheets. Goodness knows. Anonymous House and Rosie say, how was my day? How was my day? Oh, my day's been pretty good. I've met lots of people on the open days, and I've had lots of good conversations with people. I've met lots of people who really like maths, which is nice. It's a good reminder of how we're going to be okay, and years to come we'll have lots of mathematicians like you coming around answering questions. Other stuff in chat. People want to know if am I going to Wimbledon? I don't think so. Not as far as I know. And Kay's got an important question, which is, will you be able to sketch graphs? So not really. I mean, we haven't got any mechanism for you to sketch a graph and us to see that for the MAT this year. But we have questions on previous MAT questions, which have I got an example here? Oh, I don't know because my printer's been weird. But examples where a multiple choice question might have multiple options and say which of these is the graph of some function. In which case you probably need to sketch the graph and then compare against the options and see what's going on. So we can still do a kind of graph sketching question, even if it's multiple choice, to give you options. Right, do I get vacation time? I get some holiday days I can use during the year, but actually summer is pretty busy for me because summer is the time that students are not in school, so it's a good time for them to come to Oxford for an open day, or for a summer school, or for a bridging course, and then before I know it, it's the start of term again. Yeah, we should sign some deal with Desmos. Right, okay. I did meet Rosie. There we go. Right, okay, good. Shall we get going? I think we should get going, shouldn't we? We've done our vote. It was pretty good. It's about a 4-star day, wasn't it? And now maybe it is time to talk about some graphs and transformations. I'm really going to be let down by this printer. I think I'm missing. No, I think I've got it. Yeah, okay, right. I know this is weird, but it's huge. It is kind of behind me, so I also have a printed out version. Which printer? Okay, I'm going to switch off chat just so we can see more of this document. And here's the MAT syllabus. So the MAT syllabus lays out the topics from A-level or equivalent that we think people should know about, and I've got some notes underneath with bullet points with some information about those. I think this one's pretty okay. I mean, if in doubt, you could open up Desmos or something, or get a graphing calculator somewhere, or play around with these things and find out what happens. What does the graph of sin x look like? What's the graph of cos x look like? Root x, a to the x, what does that look like for different values of a? There's a bit about solving equations and inequalities with graphs, to think about the relationship between, I don't know, well, we've got an example coming up, I think, but you can describe regions of space if you use inequalities, and you can do multiple inequalities that might restrict the region. If you want all of these inequalities to hold, well, you can describe some fairly complicated regions like that. There's relationships for stretches, squashes, and translations that we expect people to know about. And that's kind of it for this section. This is the graphs bit and the transformations bit of the MAT syllabus. There are loads of other things that you could imagine being here. Last week, people wanted to ask lots of questions about things that were not on the syllabus. So maybe I'll be really clear at the top here, which is arbitrary rotations, arbitrary reflections, matrix transformations. These are all examples of things that are not on the syllabus. So if you just heard those things and if you've got no idea what they are, that's okay. The idea of MAT is to take a pretty limited list of topics and to ask pretty hard questions with them, which I'd like to get onto. So there we go. Okay. Right. Oh, what's this? So chat's already got an example possibly of that effect. Do you need to know the graphs for inverse trigonometric functions? No, otherwise they would be on that list. If you needed to know the graph of inverse sine, and do you need to know about asymptotes? Well, I think you need to be able to sketch 1 over x, which has got some asymptotes. I'm not sure you need to know the word asymptote because I can't see it anywhere on the page. You see, this is the syllabus sort of test is it's supposed to be a list of maths that we're assuming people know for that. Right, good, okay. Of course, knowing other maths is something that most people know other maths as well, just because they've been learning other things. Good, okay, right. I have this definition of a graph, which you've maybe seen at the bottom of the screen there, which I phrased in a slightly strange way. When we look at the revision questions in a moment, I think some of the hardest ones are where I'm playing with this definition a little bit. On the screen it says all the points in the xy plane that satisfy the equation. And I've written that generally enough that it could be any sort of equation involving x and y. Desmos can do this, by the way. If you use the Desmos website, you can give it an equation involving x and y, and it will have a go at showing you all the places where that equation is satisfied, wherever they might be. So that's one thing we can look at. But we also, perhaps more commonly, you might be familiar with the graph of a function, where you're given a function f and you're asked to think about all of the inputs x, bring in lots of real numbers, which, if you like, there's an equation behind the scenes there, right? Y equals f of x is an equation involving y and x. It just happens to only involve y once on the left. Special case. And those are the ones that you meet to start off with. You learn to draw graphs of quadratics and cubics. Maybe you've seen sine and cosine and tan. I've shown them here in degrees because math questions use degrees. You are allowed to know about radians, but the questions are always written as if you only know about degrees, just in case. Some people only know about degrees, it's fine. We have graphs here of things like square root x, which is a special case. Oh no, square root x is on the syllabus, so that's something we need to be able to sketch. Nice and steep at the origin for square root x, and then logarithm like this. So there's several of these graphs of functions. And then down here I've got some notes on transformations. So if you're seeing these for the first time, then you might want to pause the video and read the screen, or you might want to get the worksheet so you can read this in your own time and think about what this means. And you might like to play around with this and test what happens if you put some things in Desmos, or if you try out particular examples with straight lines or quadratics to try calculating these things. What does f of 3x mean if f is some sort of quadratic shaped thing? Yes, along with Live is currently discussing revision notes. Yes, okay. And question in chat says, sketching in an interview, I guess examiners maybe would like for you to mention that x shouldn't be 0 for the 1 over x function. Yes, I think I would like that. Sorry, just getting a thing. There we go. I've realised I didn't plug this in. Not essential. I think we're doing fine. But if I do this, and I get a button chat. There we go. Right. See, now I can press this button, and it puts chat on and off, which is supposed to be good if I'm talking to chat. Oh, I switch chat off and on again. There you go. With all of its scroll bar glory. Ginger Biscuit is here and has heard the word Desmos. Yes. So there's an anonymous person on chat who I was just talking to saying if you're talking about 1 over x, then you probably shouldn't put in 0. And if you're talking about the square root of x, you probably shouldn't put in negative numbers. These functions have a domain, which is not a word that's on our syllabus, but they have some numbers that you can put into the function, and some numbers that you can't. Being careful with where these functions are defined is important. Good. Okay, right. So I chat again. There you go, I got my chat button now. Good. Okay, so that's all I've got. I think I've got some ideas about sketching these functions. You should have seen them before, I hope, and some idea about how these transformations work to move things around. I've included some notes there about special cases to do with a reflection, which is a sort of special case of a group of transformations that have reflections and squashes and stretches in there. So the word group and distracted myself. Right, yes, that's our notes. Not a lot for us to work with. Let's try and do some questions. So in record time, I think I'm going to try and move on to revision questions. There is a poll for this. The poll for this asks which revision questions should we do, and if you're watching live, you can vote to let me know which revision questions we should focus on. There are 15 of them this week. They look like this. Question 1 has several parts about sketching graphs and telling me if they're the same or not. 2, 3, 4. They do get harder as we go along. How far down do I go before chat would like me to take over? A little bit of question 1 in there, which is interesting, and a bit of 10, 14, 13, 15. Okay, let's have a look down here. Yeah, so 10 wants to sketch various things, and I think the punchline for 10 is that it switches from being the graph of a function, y equals, to some sort of equation, y squared equals 4 minus x squared. Okay, we can have a look at that. Yes, and then I imagine that 13, 14, 15 on screen. Oh, chat is slightly on top of 13, 14, 15. I imagine that these are the ones that people found particularly difficult. I think I might have made some of these too hard. We will find out whether I've made them too hard or not. I'm looking at 15 now. And oh, did I look at this before we went live? Can't remember. Can I work out what to do on that one live? We will find out. Right, set myself a challenge. I've been at the open day all day, so normally I would look through the questions beforehand and remind myself of the answers, but oh dear. I've been talking to all of you instead at open day stuff. Yeah, they've really voted for 13, 15, 14. And a bit of 1, and actually that 2 next, so 1 and 2. Let's talk about 1 and 2 out loud. So I'm going to go back up here for questions 1 and 2. Hi chat, thank you for voting. So that's officially then, that is 13, 15, 14. 13, 15, 14, 1 and 2. Thank you. The top 5 that people have voted for. Let's have a look then. So out loud, questions 1 and 2 ask you to sketch graphs of transformations of things. And there's this question that says, is that the same as the previous graph? And the answer is, I think no, in both cases. Sort of multiplication, it matters what order you do these operations in, because f is a pretty complicated function. It's x squared plus 4x plus 3. They want an example here of a function g such that you can swap around the multiplication, and I think the trick is to pick something nice and simple. You can make it very simple as a function. For example, in that first question, if g is quite lazy and always returns the number 0, or if g just returns the thing that you put in, if it's the identity function, takes a number and returns that number, then I think your life is going to be okay. I think those things will be equal. So this does happen sometimes. If g is nice and simple, perhaps, that you could work with these things. Yeah, so linear functions, says K in chat. Very nice, good. What do I mean by factor A parallel to the x-axis or parallel to the y-axis? So if you have a square, there we go. If you have a square, you can stretch it parallel to the x-axis, which makes it wider. If you do that, then there's some scale factor for how much larger you made it. If you stretch it by a factor of 2, it'll be twice as large. That's what I mean by a stretch with scale factor. The key thing when you do some stretching horizontally is how much you've multiplied x coordinates by with particular features. So if something's got twice as wide, scale factor of 2. Then you have to think about parallel to the y-axis for some sort of vertical stretch, where again I care about how much distance is parallel to the y direction, how much they've been stretched, which has the effect of then scaling areas as well, again, because if you make a rectangle taller, then it gets larger. You could use g of x equals 0, chat. Yes, good idea. Could I explain the order in which graph transformations should be done? Well, it depends what you're trying to achieve. So in this question, there's no, in this question 1 at the top there's no choice about what order you do things in. Well, I suppose that's the joke of the question, that order matters. The thing, when I see 3 times f of 2x in their question there, shall I go to the board? Yeah, let's go to the board. So when I see y equals, oh dear, that's not a good colour. When I see y equals 3 times f of 2x, then you do this first. You do f second, and you do the 3 third, rather fittingly. So you multiply by 3 at the end. If you want to have a particular effect, then you need to think quite carefully. So if you want to do some combination, then in general the order matters. That's the point of question 2, by the way, which talks about translating by 1. Well, actually, question 2 messes around with things a little bit as well. Question 2 is a little bit about the order of translations and scale factors mattering. And what order you want to do those things in depends what you're trying to do. Yes. So Neat and I in chat, the user whose name is Neat, says f of 2 minus x. What is the order of transformation for the transformation affecting x? Yeah, good question. So can you build this by using the things at the end of the revision notes? Can you make this? So, which I would say something like, well, let's do some algebra first. something like this. I'd like to have x somewhere in there, and there's a minus sign in here, so I think I'd like to write it like this, which makes me think, because of all the brackets, that this is x minus 2 is the first thing that's happened, and then a minus sign is the next thing that's happened, and then f has been applied, and then a minus sign finally to flip it upside down at the end. A trick that I like to use for these, if you're trying to work out what the graph will look like afterwards, is to find some particular feature on the graph. So let's say we've got this is f of x, and it's got some particular feature, this middle bump or something, where I've worked out where that is as being when x is 3 and y is 7. Then in order to see that on the graph of, I'm going to draw it upside down because of that minus sign, but we'll see. In order to see that feature on the graph of minus f of 2 minus x, which is something Nee has asked about in chat, in order to see that feature, I've got to work out what value of x on my new graph I should put in order to pass the number 3 into f. So at that point where f takes over, f is controlling the shape. There's some transformations that have happened. It's flipped over and it's been maybe reflected or translated. Oh, can't do that. It's been maybe translated or reflected, but the feature there, that corresponds to, in the original world, what happens when you put 3 into the function. So I need to think about, when does that happen here? Well, it's when the stuff inside the brackets is 3, because something about f. It sees the number 3 and it says time to do that middle bump on the function. That's just how f works. It sees numbers and it returns. That's the point where it's got a bump. So I need to work out, when is this 3, the thing inside the brackets? And that's something like -1. And at that point, we get f of 3, which we know to be 7, but then a minus sign in front, so -7. And then you can kind of go from there, if you like. So we can track 1 point to work out what's going on, and maybe 2 or 3, perhaps, to work out the order of things. This is my trick for trying to evaluate where do things happen. So sort of, you can check this for yourself by, I suppose, sketching sine of x and sketching sine of minus sine of 2 minus x. Ooh. If you put those into decimals, you can check what's going on. Right, okay, that's questions 1 and 2. Try them out with some functions. And there's a mix here of thinking maybe geometrically about the graphs versus thinking algebraically about what actually happens. So if you have a particular function x there, x cubed minus x, you can just do the algebra. 2 times f of x plus 1 means plug in x plus 1 into the expression. You can multiply it out if you like, but then multiply everything by 2. And that's just some algebra that you can do if you like. Right, okay. Lots of people asked for those last 3 questions, so I'm going to skip down to those as well. Here we are. These are designed to be difficult. They're also designed to be done. Oh my goodness. Right, look at this mess. I think I've made these too hard, he says. Well, taste of my own medicine, isn't it? Here we are, doing 13, 14, and 15. We have some past math questions, and I don't know if we'll see one today, but there are some past math questions where you're supposed to spot a factorization. That something scary appears, but actually it's not so bad. There's been some sort of multiplying out. So when I see this x to the 4 plus 2 x squared y squared plus y to the 4, this stuff, so far I'm kind of happy with, because I know that this is, well, it looks like something's been squared. What's been squared? Let me think. This is a squared, perhaps this is b squared. They look like square things, and this would be 2ab. Oh yeah, okay, that's all right. This is x squared plus y squared squared. I don't know if that's helpful or not yet, but it feels like a good start. What's this then? So then, minus sign, minus 3 x squared, and actually minus 3 x squared minus 3 y squared looks like that, plus 2 equals 0, and then hang on a minute. What have I got? I've got x squared plus y squared squared minus 3 times that plus twice that plus 2 is 0. So if I write u for x squared plus y squared, then I have u squared minus 3u plus 2 equals 0. That's a quadratic. That's sort of a quadratic in disguise, something really horrible that's been multiplied out over here. So then I would factorise that, hopefully correctly. Oh my goodness. Yeah, looks good. So u is 2 or u equals 1, which means that x squared plus y squared, oh, just off the bottom of the screen. There we go. X squared plus y squared equals 2 or x squared plus y squared equals 1. That's the equations of two circles. X squared plus y squared equals 1 is the unit circle, which you might have met in some sort of trigonometry context. Points on the unit circle, you could say where they are with sine and cosine if you had to. And x squared plus y squared equals 2, that's a slightly larger circle, isn't it? Equation for a circle, it's got radius root 2. I've drawn it quite badly, but because of technology I can slightly fix that. There we go. Good. Okay, so two circles. This one goes through 1, 0, and this one goes through 1, 1. It's kind of nice. I don't know, does 1, 1 work in this? Let's check. 1, 2, 3, 4, minus, and then if these are both 1s, 3 times 6, you get minus 6, but then plus 2 again. Yep, that works out. Okay, good. I like to check the points to make sure I've got something on there. Yeah, so there was a secret quadratic here. Not so bad. That's 13. Chat's going to give me advice about 14. So 14, what can I see? Where have you seen something like this before? And can we make it work? So 14, I can see x to the 6, so I'm scared. And then I see 3 times x to the 4 y squared, so I'm less scared because this is going somewhere, right? 3x squared y to the 4, and now I've got an idea, I think. Maybe chat will let me know what they want to do. And then, what's this at the end? I can see y to the 6, and the whole thing is equal to 1. Good. So, quick look at chat. Let's see. Oh, keep them coming in. This is very good. Yes. Coefficients 1, 3, 3, 1. You see that in the binomial expansion of something that's been cubed. There really is a past math question that's like this, but a bit harder. So I think it's good stuff, chat. I like it. Yes, it's the cube of x squared plus y squared, which you kind of just need to notice, I think, that this is exactly what you get when you multiply out x squared plus y squared to the power of 3. Slightly disguised, I suppose, because these things are squared already. So you don't just have x plus y to the power of 3, you have something more complicated to the power of 3. Okay, so what do I want to do here? Right, okay, so x squared plus y squared equals 1. No other roots for this one, because this cubic only has one solution. I could write it out and say u is this thing here, u cubed is 1, so u is 1, and that's just a unit circle. Just one circle this time. Okay, it's kind of silly, isn't it? These things working with an equation, maybe you can recognize the equation, or maybe you can work and talk about how the equation factorizes. Yeah, just a circle. But how? So how, I think chat was quite helpful on this one, chat, with the comments. The how, I think, comes down to, for this question 14, the 1331 pattern for question 14. I think that's the thing that I noticed. I've seen from doing things like x plus y cubed, which I've had to work out a few times before, I know that that is this. And then the thing in the question is not quite that. Oh, sorry, under chat. Not quite that. I've got to write in such a small box. Not quite this, because everything is additionally squared. But if you've seen this pattern before, then maybe you can pattern match to what's in the question. Can you go over reflection of a point in a line? I've seen it in so many past papers. So reflection of a point in a line is not exactly on the syllabus, but I think you can work it out. So reflection of a point in a line. Have we got a past paper question on this? I can't remember. Is there something coming up? Am I going to get there? Oh my goodness, I've got the same page twice coming up in my printed version. Good, good, good. That's what I like to see. I would do some maths, to be honest, if I wanted to reflect a point in a line. I can't remember a formula for it, but I would draw a diagram and I would work out a line that's perpendicular to the line you're reflecting in, so that I can move the point at right angles to the mirror. You have like a mirror over here, and you have a point, and you want to reflect in the mirror. Well, I would work out the equation of this line, and I would go an equal distance over here, because things in mirrors appear to be an equal distance to the other side of the mirror. That's how reflections work. So this point goes over there. And to be honest, I would do that style of calculation. If you haven't learned a formula or something, I would do that step by step. Finding the line that's at right angles to the mirror, sending it through the point, and working out some distances. Some geometry. Yeah, I call that geometry too. Right. Am I stalling from doing question 15? Maybe a little bit. Maybe a little bit. Okay. I haven't looked at the solution yet. I've got it over there, but I haven't looked down yet. This could be a good teaching moment. Instead of doing question 15, I was at the open day. Let's see if I can do it now. Right, what have we got? On the left, we've got xy, and we've got xy squared. So I'm already thinking, maybe xy plays an important role, because I've got two of them over here. Then I've got x cubed, and I've got a y cubed. Oh, so that's a shame. Some of these things are squared things, and some of them are cubed. So partly I think I want to put all of these things on the same side as each other, and then see if I can spot a factor. I can see this kind of pattern that y appears y squared, y cubed, no y's at all. So I sort of suspect that this might be, it's not quite there, something's been cubed and multiplied out. Where are the threes? But maybe if I move everything onto the right hand side, I'll get an idea. How do I want to do this? I think I want those terms, and I think I want those terms, because these ones have both got x in them. That's silly. And these have both got y squared in them. That's something I want. Yeah, y and x squared. Y and x squared is what they share. So hang on, I don't know where this is going, but y minus x squared, and this is x times x squared minus y. Aha! Aha! Right, okay, so there's a shared factor. Minus signs, but this is x minus y squared, x squared minus y. I think. Quick sanity check. If I multiply this out, I'll get negative xy from the outside, which is over there, negative x squared y squared, but I'll also get a y cubed and an x cubed. Right. Moving everything onto the right hand side, and then looking to see if I can factorize it at all, or spot. Can I find some? I guess factorizing is the right direction to go, because finding a factor gives me more understanding of when is this thing 0. And I'm thinking about 0 because I've moved everything onto the right hand side. Now there's a big 0. When is this expression 0? Well, gee, it would be nice if it factorized, because then my rule would be either either x minus y squared equals 0, or x squared minus y equals 0. This is a standard parabola, isn't it? Y equals x squared, and this is y is plus or minus the square root of x. So we get square root x, y equals minus square root x. We talked about this before, that you get these two bits for this left graph, and then this one's just y equals x squared. You could write those, I suppose, both as x equals y squared. How did I get from line 3 to line 4? Yes, line 3 to line 4. What is this? So 1, 2, 3 to line 4. So I noticed, after pulling out a factor that was shared over here of x, I've got this x squared minus y, and after pulling out a factor of y squared over here, to sort of try to simplify this by grouping the terms together, based on lots of y's over there, both of them have got y squared, sort of my two worst terms in a way. I don't like having y cubed in an expression, and I don't really like y squared x squared, so my worst terms, bring out the y squared. I got this, and these pink underlined things are almost exactly the same. So if you like, I've taken a minus sign out of this second bracket and put it here in front of the y squared, so that I can flip the signs on here, and now they match. So now I can group the terms together. I have x times the pink bracket, and I have negative y squared times the pink bracket, once I've allowed for bringing out that minus sign. Sorry if I did that too fast. I was so excited that I had this shared bracket that I wanted to write down the consequence of what was going on. Yeah. Do math past papers get harder? They're supposed to get easier as you do more of them. Well, you're supposed to get more familiar with the style of what's going on. This is a chat comment, let's put it on screen. Yeah. There's several things going on here. Does 12 do the same sort of thing? I'm looking at it now. 12 says, well, it's up at the top of the screen there, isn't it? X cubed minus x. All the points that satisfy f of x equals f of y. Oh, I think you can do that piece by piece by thinking about different cases. Is x positive or negative? Is y positive or negative? Hang on a minute, how positive, how negative? Because x cubed minus x has got several things going on. And the graph turns out to be quite nice. So I think you can piece it together by thinking, when is it the case that f agrees on its values? There's a request for question 12. Excuse me. Right. Yes, that second bracket is hard, isn't it? Let's talk about that second bracket. So well done, Nee, in chat for factorising this out. So question 12. Factorising out. I'm going to take your word for it. What you've done here is that question at the top of the screen. X cubed minus x equals y cubed minus y, and then they've rearranged that to brought out a factor of x minus y, and the other bracket is x squared plus xy plus y squared minus 1 equals 0. So we have the line y equals x, that's part of it. So if x equals y, then f of x equals f of y. You put the same number in, you'll get the same number out. And there's this other part, which seems harder because it's not a circle. It's got this extra xy thing in here. So let's think about just sketching this. The points where this is true, where x squared plus xy plus y squared is equal to 1. Now, this is not a great question. I wouldn't use this as a math question because some people doing math, I think, have seen this before. Some people have just seen this, in which case it's not really fair. If you've just seen this, then you know that this is some sort of ellipse, which is a stretched circle. But let's try and work it out together, assuming that we haven't seen this before, which is the assumption I would like to make, so that this question is fair. For these ones, it doesn't matter so much because the point of the revision questions is just that you practice doing stuff and practice being stuck. Yeah, so I suppose one way to start approaching this is to think of this as, I'm actually going to move the 1 back on the left because I do like saying that things are equal to 0. And I see I've got a question in chat about the previous one, so I'll go back in a second. One way to think about this is a quadratic in x. So this is the x squared term, and then there's an x term, and then there's a constant on the end. So for different values of x, for different values of y, we get different quadratics, which might or might not have any solutions. So that's one way in, to think of this as a quadratic equation for x. So I'm expecting to see, for each value of y, 0 or 1 or 2 solutions x, because it's for a given value of y, if y is, I don't know, if y is 6 or something like that, then that's just a quadratic for x. So 2 solutions are 1 or 0. So I'm expecting some sort of blob shape or maybe some stretched out shape that has 0 or 1 or 2 values of x for each value of y. And vice versa, I suppose. For each value of y, there's 0, 1 or 2, 0 or 1 or 2 values of x, because you can rewrite that as a quadratic in y, which is kind of fun. So far I'm describing something that could be a circle, which is not quite the case. So I suppose we're probably going to have to engage with ideas about what's the maximum value of x, what's the maximum value of y, such that you still get a solution for the other number. Where's the range? Yes, you can think of it as a quadratic equation in y if you like. Let's rewrite that. There's not a lot to look at, I suppose, because it's sort of the same with the x and y flipped around, which I suppose means that flipping the x and y well, you're switching the axes if you flip x and y, which is a transformation in a way that switches the axes. So symmetry. Yeah. Okay. How did you get that factorized form? So I believe to get to this factorized form, we're working backwards now. To get to this factorized form, I believe that Ni in chat has moved everything onto the left and then spotted that there's a y minus x in there, and also spotted that x minus y is a factor of x cubed minus y cubed. That's a bit of experience, isn't it? Because we saw that on a MAT Livestream question sheet a few weeks ago, that x cubed minus y cubed has a factor of x minus y multiplied by all of this stuff. And then this minus 1 is from the fact that there's a minus sign in front of this x here. Okay, so I think I would think about the quadratic and try and work out where the solutions are and say what the average value of the solutions is, and end up with some shape where when it crosses the axes, what's going on if this is 0, I get x squared is minus 1, so I get some points around here, and it's all quite nice, and eventually end up with some shape like this, I think, not over there. Which is actually an ellipse. That's not a great picture of an ellipse. I think I've drawn more of a potato, but sort of oval shape. Hard question. I've drawn it the wrong way around. I've drawn it the wrong way around. Hard question. Yeah, because I've got to go, Yeah, tough. So I suppose compared to a circle, there's this plus xy term in here, which if x and y are both positive, then x squared plus y squared has to be a little bit smaller than it would be for a circle. So these 4 points are on the circle, but then if x and y are both positive on this graph, well, that's kind of stealing some of the thunder from x squared plus y squared. Instead of x squared plus y squared being equal to 1, there's also this xy thing around here. So this is slightly on the inside of the unit circle. And conversely, out here, it's slightly outside the unit circle. Now I've got it the right way around. It's a kind of blob-shaped kind of ellipse thing. How do you know it doesn't stretch all the way out? Well, I should probably do some quadratic formula stuff, shouldn't I? The good questions in chat. How do you know it doesn't stretch all the way out? So let's look at the discriminant for this quadratic. I'm going to look at the top discriminant for the top one. B squared minus 4ac is this, which simplifies to 4 minus 3y squared. So depending on the values of y, that might have solutions or not. That it looks like that goes negative for large enough values of y. So there's some value up here and down here where you suddenly get no solutions for the values of x. So along this line down here, just below that, or just above, no solutions for x. So this shape's bounded. It's fun, isn't it? Drawing all of this. Bits and pieces. It's a bit too hard for a math question, I think. Fun though. Yeah, intercepts in chat. Good. This isn't supposed to be content that's specifically... I don't think you should memorize ellipse stuff. I mean, at A-level, when you eventually learn about ellipses, I don't think they include this one, which has been rotated by 45 degrees. I only really know this is an ellipse because of university mathematics. And that's not a great answer, because it's the cart before the horse, isn't it? You need to do the math in order to get to university to learn the equation of an ellipse. So it's kind of silly for me to assume you know that before. So I don't. Oh yes, I should have the y equals x. How could I forget? Y equals x gives me this line here. I should put that in. Straight through the origin. First time. Right, okay. That's the sheet. There was some vote for 10 as well, which I saw briefly. Let's go and talk about 10. There's 10. So 10 wants 4 minus x and 4 minus x squared, which I'm sure you can do. and then surprise, it says y squared equals 4 minus x squared. And maybe you thought, aha, I need to think about y squared, or more. Maybe you thought, wait a minute, Morby, like a sort of maybe, but Morby. No, not at all. Wait a minute. That's x squared plus y squared equals 4. That's a circle. Because the point I'm trying to make is that sometimes you can think of this as an equation y equals, and sometimes you should think of it, is this the equation, an equation I recognise? Hey, we got there. Ah, yes, in Desmos it shows you, okay, so backing up. People have had time to type chat comments, so I'm going to go back up. Hey, it's not too bad. In Desmos it shows you a perfect ellipse. I cannot do that using my artistic skills, so do check Desmos if you want to see this curve in all its glory. And back up here, somebody says that I spotted this combination of terms quite quickly. Was that a lucky guess? I suppose I was quite lucky. This could be just pairing up the wrong pairs of terms in some sense. I was quite distracted by the xy and the x squared y squared. I was thinking about doing a substitution u equals xy, and then I saw the right hand side. I thought, oh no, I don't want to do that. I thought for a moment about x plus y, because I'm pretty sure that x plus y is a factor of this side, but it's not a factor of the left at all. So that wouldn't have gone anywhere. There's other things I could have done that would not have got me to the answer as quickly. I'm pleased with myself, but I realise I haven't done a great demonstration of thinking of how you get to the idea, because I remembered the idea too fast. They're around here somewhere. I've listed the terms in somehow just the right order. I'm a little bit trying to get the x terms. Well, no, because I moved that one off. I've got to compare the first ones, compare the second ones, but that won't always work because they might be listed in the other order. Right. Symmetry in both x and y. Oh, Rosie's telling me about symmetry. Right, okay. People are doing interpreting graphs, which is nice. Rosie says symmetry in both x and y axes. With the even powers, I think possibly talking about this one? No, which one are you talking about? Is it this one, 15? Yeah, maybe it is. No, this one. You're talking about symmetry in both x and y axes. I think you're talking about that last one, down here. And Kay wants to know whether Matt has a higher difficulty level than these questions. I think we'll get there. We'll have a look at some Matt questions as well. Some of these questions are quite hard. I wrote the revision questions, and I really want the last ones to be a bit tricky, so that we're getting ready for that kind of brain state of being stuck on questions. Occasionally I've written things that are probably too hard to be Matt questions, or too mean to be Matt questions. There was a time when we were putting this together a few years ago where, I'm not sure this actually went to print, but I had an idea for a hard Matt question that was too hard, and then thought, maybe I could put it on that live stream. There you go. Is there a trick to tackle questions? Rosie was talking about the circle. Yes, question 11 is just a grid. Lots of lines at 45 degrees to the axes. Is there a trick to tackle questions with f of x squared? Or should I just substitute values to imagine the shape? I would do a bit of both. I mean, there is a kind of common behaviour to all of these. If you want to think about sine of x squared, this would be a challenge, I suppose. So something that's going on with sine of x squared is that when you put in 0, you get sine of 0. When the numbers x start getting larger, you get some sine behaviour. And x squared gets larger faster and faster. So the numbers that are being given into the sine function are larger and larger, faster and faster, which means that you get something like this, which goes steeper and steeper and steeper and steeper. And also, if you put a negative number in, you get the same thing as if you put in the corresponding positive number. So this thing is symmetric, which is very hard for me to draw on this board because I've started at an angle. sort of faster and faster because the input numbers are changing faster and faster compared to if we just went for sine of x, where sine of x would just see the numbers x getting larger, sure, but at a steady rate, whereas x squared, my goodness, that's going to be 1,000,000 in no time. And by the time we get to sine of 1,000,000, something I find it helpful here is to think of the function as a machine that takes in a particular number. Maybe it's looking for a particular number. That's too much of a personification. The function is a machine that takes in a number and returns some number. That's partly how I'm thinking about that example we did before, looking at what the graph would look like, to say, well, the features come when f takes certain input numbers, and if you're messing around with the inputs, then, well, you can mess around, but it's the kind of final answer of everything inside the brackets that's going to be shown to the sine function. So if you'll go and square x, you'll get a huge number, and then sine gets a look in, and sine says, sine of 1,000,000? That's huge. So very quickly you end up over there, because x squared is getting larger, faster and faster. Cool. Request for question 5, which just wants some logarithms. Is this the one which I haven't fixed year on year? Is this broken compared to last year? Yes, I think it's maybe broken. No. Just the solution is different to the question? No, we're all right. Yeah, we're good. I think 5's okay. You've got to recognise the thing inside the brackets is x minus 1 all squared, and then you've got to be a bit careful with whether or not you're taking the logarithm of a negative number, but you'll be okay. Why is 11 considered a grid? So 11 is considered a grid by Ginger Biscuit in chat, said grid, because for 11, is that on screen with the cosines? 11 is considered a grid. This one has solutions where, for some of the solutions, if you think of this as an equation that we're trying to solve, for some of the solutions, x is equal to y. You put the same number in, you get the same number out. But there are other ways to see the same value of cosine. One of them is to increase the value of y by 360 degrees compared to x, which gives you lines like this, or 720, or so on. So you can draw these lines. What happens if you add or subtract 360 degrees, you'll get the same value of cosine. So that's another example of cos y equals cos x. And something else you can do is you can set y to be negative x, because that's a symmetry of cosine, isn't it? That cosine has reflectional symmetry across the y-axis. So y could be negative x, and they would have the same value of cosine. And you can combine those ideas, that y could be negative x plus 360. Because adding 360 doesn't change anything to the value of cosine x. So we end up with this square grid, a perfect square grid. A perfect square grid with no notes. Oh my goodness, that's a point supposed to be on the y-axis. Right, a perfect square grid. Scroll it off the screen. There we go. A perfect square grid at 45 degrees. There are lots of crisscrossing lines. That's why Ginger Biscuit said grid for that. They're thinking about kind of potato waffles or something. Right. If you differentiated sine x squared, that's Aaron in chat, and I'm going to stop Aaron there because in order to differentiate sine x squared, you need the chain rule, and the chain rule is not on MAT. Not expected to be able to do that for a MAT calculation. Okay, but you're correct. That is right. And then the gradient does get very large for large x. Good. Yeah, true, but not the MAT syllabus. So I'm going to hide it. There it is. It's gone. Okay, those are some revision questions. We're about to get up to 6. I've been requested to do this one once again. So I'm just going to label my lines. And you can check whether you agree that all of these lines are part of the solution. They're examples of times that cos y is equal to cos x. And you can also check that I've drawn my lines correctly, I suppose. The picture is not amazing. X minus, oh gosh. X minus 360 degrees. There we go. And then this is y equals minus x. I'd like you to check that that's an example of a time that cosine y is equal to cosine x, because to think what cosine does, and off we go, minus x plus 360 degrees, y equals minus x plus 720 degrees, y equals minus x minus 360 degrees. Good. I just want you to check that you believe that all of those lines, any point on that line, doesn't matter what the number is, but the kind of behaviour, the thing linking y and x, could be of one of those formats. That gives you a whole grid. Whoops, okay. Is sine x equals sine y the same as cos x equals cos y? My gut instinct is no, worry about negative signs. Worry about negative signs. But then maybe that fear is misplaced. Yeah, sine x, sine y doesn't have the same. Yeah, it doesn't have the same behaviour under negative signs, does it? It's not the case that y equals minus x should be part of that graph. So we need to be a little bit careful. So sine x equals sine y should be slightly different. Should we stick them in Desmos? We're coming up to a break. I'm going to stick them in Desmos, I think. Oh, I love Desmos. Right, back to full screen. Back to full screen. So Desmos, this website that I like. Can't use it during exams, but we can use it to test our intuition. So cos x equals cos y. That's something we've been talking about. A nice grid, including the line y equals minus x. I'm just going to switch this to degrees. Switch to degrees. There's the big degrees button. I need to zoom out quite a lot. That question's written in degrees. There we go. And then I'm going to try sine x equals sine y. Aha! So also a grid. Some of the lines are the same. Some of the lines are different. So there's the cosine one. And there's the sine one. And it's not got y equals minus x, because sine of minus x is not always the same thing as sine of x. It is sometimes over here and there, but sine of minus x is not always the same thing as sine of x. Desmos mentioned, there you go. Right, okay, so both of them together give me this rather pleasing pattern where some places where it's both, some places where it's neither. Dashed lines or something? Dashed lines? Oh, very good. Okay, dashed lines. And then they sort of fill together to make a purple line over there. I don't love that because the dashing is slightly inconsistent. Oh, scrolling is painful. Right, good. Okay, that can go away now. Right, good old Desmos. My picture's there, just as good, I think. Just as good. Yeah. K and chat is using radians, but I agree with them. Okay, coming up to 6 o'clock. If you've been looking at the screen for the last hour, please remember to look away from the screen sometimes as well. I'm just going to drink some tea very quickly and put up some MAT questions. Have I got a vote for this? No, I don't have a vote for this. You're going to have to let me know in chat what we should be looking at. We've got some short questions. This one is in the thumbnail. It's the combination of transformations, which is something that some of you asked about earlier. We've got this question, which is an example where you are supposed to, it says sketch the graph. That's because I've modified the question. The original question had options for you to choose between. You could look up the old question if you want to see the options. And then we've got some long questions, which I hope we might have time to look at, like this transformations one, which also has 2 to the power of a quadratic, and extension. The extension problems, just to be clear, are just for fun. They're not part of the MAT question. We wrote some extension questions, partly just because if you've finished the MAT question and you want to think about the thing a bit more, then there's some ideas in there. And that includes the sketch of f of x squared, which somebody asked about just now. Another long question here, where we have a particular function. Oh dear, my printed notes are all over the place. Yes, have I got this one at all? Oh yes, okay, x to the 1 over k. And there's a bit of integration in this question as well. MAT often blurs topics together, so it's sometimes a bit hard to put together MAT questions for these worksheets on a particular topic. Right, okay. Cool, okay. Since it's the break, I'll give just a ginger biscuit. Come on, I can talk. Ginger Biscuit is a user in chat. They asked for a t-shirt update. The t-shirt that I ordered has arrived in the post. Very exciting. Might be not in time for me to wear it out the open day, but I've got a new maths t-shirt that I designed that I can wear around now. So I'm looking forward to that. Yes, there's some sort of scary integral there. Oh, bye, Aaron. Take care. See you. They say goodbye. I don't want to see the math questions. Okay, right. What are we going to do? There was some request in chat just now for focus on longer questions, so we can do that. Maybe let's have a quick look at the short questions, just to say what we would do. This one wants a graph of minus f of minus x, which is a combination of stretches, or if you like, a combination of reflections. What happens when you do those two reflections? You can check your answer, I suppose, by checking some points on the graph. And there's this question, which is in the thumbnail. I would approach this by completing the square up in the exponent. I think I can only really deal with these sequence of transformations if there's an x somewhere and lots of things happening to x one at a time, but not introducing more x. So if I see x plus 3 all squared minus 2 divided by 5 add another 6, this is fine. If I see x squared minus 4x, then that's another x. Too many things to think about. So I see that as x minus 2 all squared minus 1. Well, 2 to the power of minus 1 is nice. So maybe this is going to be fine. And then the question is, what sequence of things happened there? Right, okay. Ginger Biscuit also wants to know if they can get the t-shirt. I want to double check the maths before I do something. I'll let you know. Let you know if you can get the t-shirt. You haven't even seen the t-shirt yet. Yeah, good, right, okay. And Kay, bless you, Kay, asks if you study at Oxford, you have opportunity for me to teach. I teach at New College at the moment. I've just been renewed to teach at New College next year. I teach some of the applied maths, just a little bit of the applied maths to the New College students. And starting in September, I'm also going to do some introductory lectures for everybody. So new thing that I'm doing this coming academic year is teaching everybody some introductory maths. A kind of natural follow-on from the MAT Livestream, right? You do the MAT Livestream while you're applying, and then right at the start of the course, there's an introductory lecture with me. I'm looking forward to that quite a lot. Right, okay, here we are though. We're going to do some long questions because we have a request. Who was this? AOL in chat. AOL, yes. Asked for long questions, so long questions. What I will do. Past all the hints. It's quite annoying having to scroll past all of these hints up and down, right? If you would like to simulate me standing around giving you hints on math questions, something you can do is to get the question sheets and instead of watching the live stream, just as you feel like it, trying the question and sometimes looking at the page of hints in that document as well. Good, okay. Chat messages now. If loads of people watch the MAT live stream, does that mean that loads of people apply to a new college? And surprisingly, that hasn't happened yet. Let's just say we've been doing MAT live stream for 4 or 5 years, and it is yet to be the case that everybody applies to new college. But I can try. I suppose I'm only renewed for 1 year at the moment, so who knows who's at new college? Might still be me. Good. Very grateful to New College for the teaching. I love teaching. Right, good, okay. Right, okay. I'm in open day mode as well. I don't know if you can tell. But open days are a little bit about telling people about colleges, and all of the colleges are great. People today who visit Oxford have been visiting the colleges, and every college they visit will say, well, look, we're friendly, we're lovely, we really want best students, and we're going to show you around. And all the colleges are great. They all get the same maths, because whichever college you're actually at, you get taught the same maths courses. You get the same options, you get the same exams. So in some sense, it doesn't matter which college you apply to. Good, right, okay. Here's Matt, 2008, question 3. It's a graph of y equals f of x. And as soon as I see that graph, I'm thinking, seems a bit familiar, doesn't it? I reckon I can guess a polynomial that would do something a bit like that. That's not the question. I think we never work out what function this might be. If we had to, maybe you could let me know in chat what function you think that might be. It was hard to tell, isn't it? They could have added some extra stuff, but looks kind of nice to me. Okay. On the next three pairs of axes are graphs of, and then there are three things: f of minus x, f of x minus 1, and minus f of x. So three different transformations. So I picked this one as one of our long questions because I think it's a good test of just straight away, have you worked out what's going on with these transformations? When you see those three things, you know what they are. So one of them is a translation, two of them are reflections, or if you prefer to think of those ones as stretch with scale factor -1. Goodness me, so a length gets stretched by a factor of -1, means that instead of being, so I'll keep 0 at 0, instead of being maybe a length like this, it becomes a length like this over in the negative direction, and vice versa. Negative is positive, positive is negative. What a strange way to describe a minus sign. What am I doing? Yes, chat's into this. Ooh, okay. Is it a cubic? Why is the graph of polynomial of degree x has up to x minus 1 stationary points? Good question. It's fundamental theorem of algebra, I think. Let's put this chat question on screen. I'm going to allow myself to be distracted by this chat question. Here. Calculus question to start off with, right? Because when you differentiate, your stationary points are points where the derivative is 0. And you tell me you have a polynomial of degree, you say degree x, I'm going to say degree n. So if you have a polynomial of degree n, then once you've differentiated it, you'll be left with a polynomial of degree n minus 1 because of how differentiating polynomials works. So, then hard question, why has that got up to n minus 1 stationary points? And the answer to that bit is the factor theorem. That for each root of that polynomial, each number that you can put in, that gives you 0, the stationary points where the derivative is 0, each number that you put in corresponds to a factor that you could bring out of that polynomial. So if, I don't know, if 2.5 works as a root for the derivative being 0, then there's a factor to your derivative. So you can pull out a number there. I've realised I can do this with the factor theorem instead of the fundamental theorem of algebra. Yes, so you can pull out all those factors, and the reason you're limited to n minus 1 is that you're going to run out of degree. Every time you pull out one of these factors, the degree goes down. And you started at degree n minus 1, so that's as many factors as you can pull out, as many roots of the derivative polynomial, as many stationary points as you can have. It's kind of layers of maths there, which is pretty nice. Other people in chat are guessing the polynomial, which is pretty good. Ooh, x cubed minus x squared plus minus x. Yes, repeated root maybe. I think repeated root, this one with a minus sign there, please, because I want a repeated root at a positive number. Yeah, other way around. Good. Okay, so that one's got three roots, including the origin. Here we go. Right, good. If you want a proof of the fundamental theorem of algebra, there's a really good diagram in the Oxford Online Maths Club at the start of this year, just for fun. One of our students, Beth, came on and told us about the fundamental theorem of algebra and the fundamental theorem of calculus. It's a great diagram with the further reading notes. Beth has also given me a sticker from the Mirzakhani Society, which is the Women in Maths Society at Oxford. It says, it's on my water bottle, it says, girls just want to have fundamental theorems of calculus. It's quite wordy. Girls just want to have fun, and then it changes font, demental theorems of calculus, which I love because I teach fundamental theorems of calculus to, well, everyone, but nice to know that that's what girls want. Good. Very pleased with the sticker. I also have that on a t-shirt. Good, right. Big fan of the Mirzakhani Society. Good, okay, we're doing a math question, aren't we? We've got some transformations. Yes, also number 5 video if you're interested in fundamental theorem of algebra. Right, chat's going away so I can show people some graphs. Maybe you've had time to think about what will happen when you do these transformations. One of these looks like a translation, doesn't it? This last one looks like a translation. And then we've got 2 graphs that look pretty similar. My goodness. Which one's been flipped left, right, and which one's been flipped upside down? That's a hard question, isn't it? But I suppose we can think about the intersections with the x and y axes to work out that that middle one has been flipped left, right. So it's f of minus x, and graph A has been flipped up and down. It keeps the same roots. So it's minus f of x. It's 0 in the same places. There's a difference there, isn't there? It's 0 in the same places for A, but not for B. And the y-intercept changes for A, but not for B. So some things are the same and some things are different. There's not that many cubics you can draw, though, really. I can't draw that many cubics before I draw 2 that look the same. So some of these look quite similar, don't they? They're kind of different, but similar. Good, right, okay, graphs. The question then goes on to ask us to draw both of these, and this is about transformations again. This is a similar idea to that short question we just skimmed past. Now, okay, this is a past question which asks us to sketch, and if this were a math question this year, then I really shouldn't be showing it to you on the live stream, should I? But if it was a question this year, it would have to be a bit different, because a question this year can't just ask you to sketch. I suppose it could ask you to talk about it and explain, or it could show you some options and get you to select. It could be a long question or a multiple choice question. Those are the options. Was it BCA in the end? Yeah, I think I agree. BCA. Minus f of x is kind of the easiest one to think about. No, that's A, so A should be last. Yeah. Okay, right, so 2 to the minus x squared. This is a challenge, isn't it? It's sort of a function of x squared. So something we should think about for this graph, let's tidy that up a little bit, sorry. Something we should think about for the graph of this function is, well, we could look for intercepts. Maybe you know about powers, they have a 0. What happens when x equals 0? Where does it cross the y-axis? And we could think about what happens when you put in positive and negative numbers. Because I know about x squared, and then after that, okay, there's a 2 to the minus, but once I've done the x squared, then I've lost information about positive and negative numbers, if you want to think about it like that. So I get some number over here. I might think about what happens when x is very large, or even not that large, because we've said before that if you're doing x squared, then you get to numbers like 1,000,000 really quickly. And then this will be minus 1,000,000, and this will be 2 to the negative 1,000,000. That's tiny, isn't it? 2 to the negative 1,000,000 means 1 divided by 2 to the million. A half of a half of a half of a half 1,000,000 times. That's tiny. Tiny, and after that, very flat. It can't go negative and it can't be 0, so it's going to be very flat over there. And I suppose it's got to come down from there. And over on the left, when you put in a negative number, you get the same thing as if you put in the corresponding positive number. So like that. And it doesn't cross the x-axis. And I think it has to just come down. And then my last question is going to be, what's going on near 0? Is it pointy? Is it flat? Is it something else? What's going on with this y equals 2 to the minus x squared graph? I think pointy would be a bit surprising, to be honest, but you can let me know in chat what you think. Is this question easier if you've seen normal distributions? I guess there's an experience bit there, maybe. Yeah. Perhaps it's easier if you've seen a normal distribution. there's a translation element to this, which might be important. I think you can work out the graph of 2 to the minus x squared quite quickly, whether or not you've seen a normal distribution. And hey, if you've seen a normal distribution, you'll know that that's e to the minus something. So you've got to get an e in there. So you'll be messing around with logarithms while other people are getting on with sketching it. It's not even obvious to me that that's a quicker way of doing this with your experience. I don't think we should differentiate it. Clue, if you were going to differentiate that, you'd need to use the chain rule, and the chain rule is not on the MAT syllabus. So you could if you like, but I think that the direction I was going is more like, it's probably not a spiky thing. X squared is nice and smooth, flat, and 2 to the minus x is nice and smooth. The composition of nice smooth functions should be nice and smooth, shouldn't it? Yeah. We're putting in 2 to the minus 0, and if x squared is just a little bit bigger than, if x is just a little bit bigger than 0, then x squared is still very close to 0. You have to make x really quite a lot bigger than 0, like almost a half or something, before you start to notice, oh gosh, x squared is still a quarter, that's still tiny. So it's sort of the opposite effect, isn't it? For large numbers, x squared is much, much larger than x, but for small numbers close to 0, x squared is quite a bit smaller than x. Diagram, y equals x, y equals x squared. Not a good diagram, but here's my point, that x squared gets super large, much bigger than x, but there's a crossover, and if x is small, then y equals x squared is much, much smaller than x. Which means I think that you can put in reasonably small numbers and get very small things for x squared, so they're very close to 0. Which means I'm going to say, for quite a while, this is basically like 2 to the minus 0. So I'm going to draw one of these. Nice and smooth. And symmetric. It's not very symmetric, is it? I put my head on one side and it doesn't look any better. There we go. Good enough. No spikes. It's nice and smooth. Yeah. Small amount squared doesn't change it too much. Good. Okay. The question, I think, wants us to translate this. Oh, sorry. It asks for 2 to the 2x minus x squared. But I've said before that for a quadratic up here, I would prefer to sort of complete the square, I think. So maybe we'll do this. I'm trying to complete the square in my head. Here we go. Oh my goodness. Minus, 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 plus 1. Right? Minus, 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 plus 1? Oh, that's a dangerous calculation to try and do in one line. The odds I've got all of those minus signs right are pretty slim. Minus, minus, minus. I think I've got away with it. Oh, where the stationary points. So without differentiating, stationary point at 0, because that's definitely the maximum value of this function. You can't make it any larger than that, because 2 to the minus x, well, that would be larger if I could make x negative, but this is 2 to the minus x squared, and I can never make x squared negative. So 2 to the minus x, like this. It does get larger if you could put in a negative number, but x squared has got this hard limit that you can't make x squared negative. So the biggest value I can make is this in the middle. Once I know it's the biggest value and this function is, I imagine, nice and smooth, that means that it's stationary points at the top and nowhere else. It doesn't attain a minimum over here, it just keeps decreasing slower and slower. So that's all the stationary points. For this one, the stationary point's being translated, right? Yeah, so we're going to do, on the same axis, different colour. So this function is translated, it's a version of that, but translated, and that plus 1 on the end means times 2. Because powers work like that, don't they? We've got a live stream about logarithms and powers, I think it might be next week, where some fluency with being able to move around things in the exponent into things outside. It's something we will talk about next week. So I think this is a translation to the right, so that if you put in a number like 1, then you get minus 0 squared, and also a stretch upwards. So I think it's going to be twice as tall, but over to the right. I'm going to draw this. Oh, not 2, that's the value. And this one to start off with was at 0, 1, wasn't it? So 1 to the right and twice as tall. How did I figure out the general shape of this curve, it says in chat? Well, to be honest, this curve is kind of boring, but I know the range of x squared. It can be any positive number, and then I know what happens for 2 to the minus any positive number. 2 to the minus positive number, so well, it could be 2 to the 0, and then as you make that positive number more positive, 2 to the minus positive number, well, it just goes to 0. It gets smaller and smaller and smaller. It dissolves away, doesn't it? So I kind of have drawn a disappointing function that has something interesting going on when you put in x equals 0, but away from that, like 2 to the minus stuff, it's just gonna go smaller and smaller, isn't it? Should I think about y-intercepts? I probably should think about y-intercepts, shouldn't I? The question doesn't ask us to, but why not? Doesn't hurt, does it? Doesn't hurt to say when you put in x equals 0, you get 2 to the 0. 2 to the 0 is 1. Oh, now I feel like I should label that. Oh, maybe I do want to do this. And draw like that. So that it goes through that point as well. Yeah, I probably should have thought of that. That looks important now. Good question, thank you. Yes, y-intercept of pink curve. People are being nice in chat. They're encouraging me to think about it rather than just telling me my picture's wrong. Thank you, chat. Very kind teaching from chat. Yeah, so both of these things, if you put in 0, you get 2 to the 0, which is 1. Right, okay. I should have spotted that. I should have thought about that, really, shouldn't I? Yes, thank you, chat. Okay. And then we've got a question for part 3 down the end here, thinking about translations of this curve and what you get when you integrate it. So let's try and sketch translations of this curve. I'm going to draw it a bit taller, I think, because I enjoyed drawing the pink one more than the blue one. So I'm just going to roll with that. I'm going to try and draw it in 1. Here we go. So it's very negative, and it comes up. That's maximum, and it comes down, and it's symmetric because putting in positive numbers. This is supposed to be another picture of 2 to the minus x squared, but I've made it taller, so I can see I've scaled up my axes, which of course visually has the same effect as scaling up the graph. My axes aren't labelled, so who knows what's happened there. Everything's relative, isn't it? How tall is tall? Where is 1 on my y-axis? Anyway, right, I'm having fun. We're asked for, this is a bit tricky, the integral from 0 to 1, which we can't do because that's not a function I know how to integrate. But we're interested in the integral from 0 to 1, so between these lines. And we need to remember that the integral is something to do with the area under the curve and between these lines, x equals 0 and x equals 1. We would like to make this integral the largest that we can. And the control that we have is that actually, instead of just talking about this function, we're talking about these things after they've been translated to the right by some value c. So I'm interpreting this thing in the question, 2 to the minus x minus c squared, as a translation of this graph that I've drawn to the right. And the question is, how far to the right should you translate it if you want the area to be as large as possible? Which is supposed to be, I think, just something that you can think about and try to apply some sort of common sense or thinking about it nicely. As you move it to the right, do you feel like you're gaining more on the right than you're losing on the left, because you see the value on the left is going down, so I've got less stuff over here than I did a moment ago as I shunted right, but I'm gaining stuff over there. And of course there's a nice symmetric way to arrange this. Yeah, so it feels like surely it's when C is 1/2, because otherwise, if you're a bit asymmetric like this, if the value up here is larger than the value over here, let me circle some points. If the value up here is larger than the value down here, then shunting a little to the left will give me a bit more area from large values moving into my region, and I'll only lose a little bit of area from small values moving out of my area. Actually, that looks quite good, doesn't it? I'd like small values to move out of my area. I would like to get more functions. I get more area underneath for this region. What's going on between 0 and 1 and under the curve. So I'd like to go left a bit. I think I've overshot. Yeah, so I think the maximum comes when C is 1/2. And this thing is parked right in the middle, get the large bit of the function right where I can see it, right in my range of integration, so that I will get a large value for the integral. Good. It says briefly explain your reasoning. You're not being asked to calculate it. It's pretty hard to justify it without calculating it. So I think some sort of brief discussion of why that's the case. It feels like we could do that brief discussion, you see. Even these days on MAT, where you write explanations using a keyboard, it feels a lot like you could write that justification using a keyboard, even though you can't type an integral sign, and even though you can't do this integral, there's still something to talk about there, which is quite nice. Okay, right. If this were a question on the MAT, how would you write down that explanation in a way that will make sense to the examiner? Yes, I think I would do a sentence about how when C is 1/2, you get large values, relatively large values of the function 2 to the minus x minus c all squared. I might give that a name or something, or say the function inside the integral. I would say you get relatively large values of that between 0 and 1, so you get a larger area. I'd need to demonstrate to the examiner, I think. I need to demonstrate to the examiner that I've realised that the integral is about an area that I'm trying to make large. So I would like large values to get a large area. So that's my kind of overview. I think I would do a sentence to say I would like large values to get a large area. So the large values are near the maximum stationary point, which after I've translated is near x equals c. You get large values. And then I think I would do an argument to say if c is greater than 1/2, I would like to move the graph to the left so that I get more area. And I would say something pretty vague about how moving to the left increases the area because the values go up on the left. Up on the left faster than they go down on the right. So I sort of move in more of these large values and lose some small values. Yeah, that's it enough, isn't it? The value up here is larger than the value down there, so I'm losing a bit of integral but gaining quite a large bit. I would write down a sentence like that, and then possibly something the other way around to say that if c is less than 1/2, then moving to the right increases the value on the right, decreases the value on the left, so the overall area can increase more on the right. I'd write something like that, quite woolly, I think. Just quite a lot of words on these things. I think I'm talking about the gradient, which is, I'm trying not to do this properly in a way. It says explain briefly, and you're not expected to know how to talk about the rate of change of an integral under a variation of a parameter within inside the integral, because that's hard. But you're supposed to be able to reason intuitively about how to make an area big. You want the big bit of the function. If this is a very wonky loaf of bread, and you've been told you can cut yourself a slice of bread of a certain thickness, well, then the greedy thing to do is to line up the bread right where the slicer is, with a nice big chunky bit of bread in the middle, and then slice, with it, lining up your knife with right in the middle bit of the bread, whereas, oh, brilliant. Sorry, I've been making bread and it sometimes does come out in quite a funny shape, and there is a tactic to which bit is going to be the slice for my toast. Right, bread-based analogies are available. That one feels regrettable somehow. Half 6, how are we doing? You could talk about how you want the point. Oh, right. Can you talk about how you want either side to be at the point of inflection? I'm not sure you do. It's not obvious to me that the point of inflection's got anything to do with this. I'm not sure it does. You could talk about points of inflection if you want. I don't expect you to be able to find the points of inflection for this function, so it's going to be a bit of trust, isn't it? You'll tell me something about points of inflection, and I'll think, oh crikey, have they calculated the points of inflection? Surely not. And then we'll go from there. I've seen the 2026 practice test, and the questions are pretty easier than these previous year questions. Ah, that's nice. They're taken from previous past papers. We didn't make up any new questions for the practice test. They're all past questions. Have to explain it like smoothly? Question mark. Linguistically speaking, because that would be a bit hard for non-natives. Linguistically speaking, we have English language requirements, and the course is taught in English. So sorry, but the questions are in English, and also the course is in English. So it can be a problem, I suppose. Okay, right, good. Let's look at the other long question, shall we? We're doing really well. Hints for this. Oh, were my hints any good? Let's have a look. Constant C is chosen such line y equals C. No, that's the next question. What am I looking at? Remember the extension on the previous worksheet? Oh, I didn't do the extension on the previous worksheet. Sorry, past James. I can't join in with that hint. Oh no. Translation was important. Right, okay, I'm supposed to go back to the previous sheet and try the extension material. Right, okay. Really caught myself out there. Wow. Remember the extension on the previous sheet? Well, here's the extension on this sheet. Oh, I'm skipping over it. Wow. Absolutely caught myself out. What's chat saying? Are you not allowed to differentiate it with respect to C? I don't think you know how to differentiate it with respect to C. I mean, maybe you do. Maybe you know the chain rule, but you don't need to, I think. You're not expected to. Hello, Hector in chat. Nice to know you enjoyed the open day. Nice to meet you. If I met you, I'm sorry, I met lots of people today. And Joe says about weight of MAT score. MAT score is very important. You've asked for the comparison with interviews. So if we're assuming we're at the stage where we've shortlisted and done interviews, then interview is pretty important because we can ask more questions at interview that we haven't asked on the MAT. You could find out what you think about other sorts of maths as well. I think interview is pretty important. We don't have an official numerical weighting on these things. We don't combine the numbers together. But broadly speaking, if your interviews are very good, then that's enough. If your interviews are kind of okay, then anything goes. Tutors can look at all sorts of information from your UCAS form, your MAT, your interviews. They've now met you. They can take all of that mathematical information into consideration as they make those final offers for their cohorts. So in some sense, interviews, if they go extremely well, then sometimes you just have some interviews with a person and you think, this person's amazing, we should obviously make them an offer. And sometimes, more often, you have several candidates who have had a kind of mixed experience or an okay experience. You need to choose between them based on everything. Yeah, I agree with Anonymous at the top. Yeah, it would be nice if we could just integrate and differentiate and call it a day, but they've designed the function in that previous question to make it a little bit too hard to do that. And it said explain briefly, so I don't really want to go and do lots of work. If I score somewhere between 65 and 75, that's all right. That's an all right MAT score. But other academics, yeah, supercurriculars, yeah, personal statement are nice. Do I have a chance? Yeah, I'd say you have a chance. And of course, I think you should aim for 100. You should aim for more than 65, 75. You should aim for the moon. Right. Okay. How are we doing? I'm slightly losing my voice from 2 days of open day plus 1 hour of live stream and 1 hour and a half hours of live stream. We're going to have a quick look at this other question that I've picked out, which does involve some graph sketching, but not a lot. So maybe we'll sketch some graphs, and maybe we'll look at the structure of the question. No, most people do not get 100. Not many people get 100 on the MAT. There are some years where nobody gets 100 on the MAT. That's not uncommon for nobody to score 100. The test is designed to be really hard. The graph of MAT scores looks a bit like those functions we've been drawing, where there's a maximum around about 50, which is the value you should choose if you're translating it to maximise the whatever, never mind. Difference integral with respect to C. The integral becomes soluble. I guess technically, but you're still using the chain rule. And then you can go solve it. Yep, sounds fine. Some of these older math questions are a little bit susceptible to other maths. I think we've maybe got better at writing questions where you don't get an advantage if you know the chain rule. And that's one that I've seen a few times. That if you know the chain rule, you're not supposed to have an advantage. Could you use your MAT score for other universities? No, sorry. Just for Oxford. Sorry about that. Okay. Right, thanks chat. Ooh, what does Callie say about do many people get 100? Callie has the link to Callie has mentioned the feedback reports in chat, which is a reminder, yes, that on the table of past papers on the MAT page, which you can get to by going to MAT Live, backspace, get back to /r/MAT, or go to that link and click Maths admissions test near the top. You'll find a table of past papers, which also has feedback, which has numbers about the admissions round that year, number of people we admitted, and also a graph of MAT scores. So if you want to see the graph that I think I alluded to about the distribution. Is there a reason why there are people who get 80 plus and do not get shortlisted? Yes. Well, not really one reason, but yes, there are candidates who get more than 80 and do not get shortlisted. That's not the usual thing to happen if you get more than 80, so you shouldn't worry about this. But there are candidates who get more than 80 and do not get shortlisted. Really not very many of them. Right, okay. Let's have a go at sketching some functions. I think we're just going to draw a few here in the first part of this question. Yes, that's it. Fk, some f subscript k, a function of x. So I like to think of these as maybe being a sequence of functions, but that's perhaps a scary idea, that a sequence of functions, because there's function f1, there's function f2, and there's function f3, which maybe it's scary to think of those as a sequence that might go on forever. In fact, it's worse than that. Oh no, it's good. That is as bad as it is. They keep going because it says for each positive integer. But if you prefer, then you could think about the values that these things take when you give them a value x, which is, in the first case, x to the 1 over 1, which I'm not going to write down, x to the 1 over 2, and x to the 1 over 3, which you might prefer to write as square root of x, and maybe, I'm not sure I love this notation, but cube root of x might be something you write down to help yourself feel familiar about the things that we're being asked to sketch. Then you'll draw the wonkiest axes you've ever drawn. Wow, like a little graph of x cubed instead of an axis. There we go, that's a bit better. Off we go then. So we've got to draw y equals x. Y equals square root of x. And y equals cube root of x. So I've got to think a bit about whether the cube root of x is larger or smaller than the square root of x, and also that square root of x versus x as well. All of these are 0 when you put them 0, aren't they? And then going on. Oh, wait, what? James reading the function out loud just ruined this question for me. What did I do? In a bad way? Wait. I ruined the question for someone just by reading out the function. Did I say something bad? Oh no. Do you want to go into more detail? I'm really sorry. Or maybe just ruined in the sense that now you know what's going on. That would be nice, wouldn't it? Maybe it's ruined in the sense of, aha, I can see what's going on. Can't shake the feeling that I said something I shouldn't have said. Here we go. Okay, it's been a long day. Right, so square root x over here. I'm going to draw, so I know it's very steep, so I think it's larger. And then at some point, I suppose it crosses over. When would these be equal? Oh, when x is 1. Square root of 1 is 1. And cube root of x. Right, now I've got to think. So when x is large, the cube root is definitely less than the square root, because if it's something like 1,000,000, then the cube root is 100, but the square root is 1,000. So for my cube roots, and this is most of my square root. Oh, I'm underneath the chat now. Ruining questions. It's James's voice that transmits the solution. I see. So I told you that it was f1 was x, and f2 was the square root of x, and that maybe gave things away a bit. They're not as bad as you think. I've drawn that very badly. That's really bad. I've drawn it with a negative gradient. Didn't mean to do that. Let's have another go. I'm trying to draw it lower, but still above the number 1. And then I suppose I'll draw it higher over here, which just feels like inertia on my part. Oh, that's really bad. Sorry, if you draw slowly on this. Right, I'm going to lock in. Here we go. Oh, that's terrible. That's much worse. I've become so bad at drawing. No. Come on, 10th time lucky. That'll have to do. Cube root of x, everybody. I think that cube root of a very large number, like 1,000,000, is smaller than the square root of a large number. The same large number. And conversely, if you have small numbers like 1 over 1,000,000, then the square root is smaller than the cube roots, because everything is kind of 1 over in that world. So large becomes small, small becomes large. And then there's like a bit of inertia going through here. It comes in lower, it comes higher on the other side. Yeah, so you can also draw graphs of x squared and x cubed and switch the values of x and y, which we've talked about a couple of times. It's a good trick if you know it. So let's try and hold my axes the same way round as the screen, which is... Am I mirrored? I had a stretch with scale factor -1 that's being applied to my video feed. Right, okay. There are your axes, x and y, and there's this way to swap them, which turns the x-axis into the y-axis and the y-axis into the x-axis. And that swapping is a kind of, if you like, a switching or a reflection, which sort of says turn things around. Not quite just turn them sideways. I don't like thinking of it as turn it sideways. It's a reflection in the line y equals x, which is a bit of a complicated thing to think about. But this switching like this, not a rotation, switching. Okay. Yeah. So in chat it says rotate the x-axis. I think I want to interchange, not a rotation of 45 degrees. Chat says rotation of 45 degrees. I'm nodding on the screen because it's not a rotation. Oh, 45 degrees. What are they thinking about? They're thinking about something else. They're thinking about something else entirely. Okay. I've drawn some curves. Not very well. Maybe you can do better at home. That is a challenge. Okay. Then we've got several regions, and we're asked for the area of the region between, oh my goodness, fkx and fk plus 1x. And at this point, we're going to have some limits. We're going to know which one's which, but we can integrate each of them to find the area underneath. We talked about this last week or maybe the week before, to find the area between two curves, you can use the thing you know, which is that integration gives you the area under the curve, and do some subtraction to subtract the area you don't want. And part of that question there in part II on screen, part of that question is to work out which area you want and which area you don't want, which involves thinking about fkx and fk plus 1. So yes, AOL in chat is correct. You could just integrate, but you should put the 1/overs in there as well. Fkx has this 1/k in the power. Yes, we should just do some integration and some subtraction. One of the nice things about integration and subtraction is that they play together in a pleasant manner. The difference of two integrals over the same limits. The difference of two integrals, well, you can just take the difference of the functions and integrate. Everything just plays nicely. Is that obvious? Quick break. We've only got 15 minutes on the stream, but just quick check. Something I've just claimed there, I'm not sure if it's obvious. This would make a good map question. Too late now. I want to put brackets around the outside there to show you that it's all of this that's being integrated. You can smush them together into one integral with the difference in the functions. And that's because you know about adding together integrals, and you know that you can pull out a factor. So to prove this, I would say that this second one here is the same thing as integrating negative g of x this minus sign, you could bring it inside the integral. You can move constant numbers inside or outside the integral. That's just something you can do. Making the function, scaling up the function scales up the area. Graph transformation. Scaling up the function scales up the area. I suppose I don't really mean area because I'm also talking about negative numbers, and areas are always positive, but you know what I mean. It scales up the value that you get for that integration. Possibly flips the sign. Integrals can be negative, areas are supposed to be positive. And then the second thing I want to use is that you can add integrals together. So I suppose, I don't know how obvious this is, sorry, but maybe you were aware that you could add integrals together, but this also means as a result that you can subtract integrals over the same limits. I've got a lot of brackets over here. I think it's the right number. There you go. So my proof goes like this. You've got a rule about moving numbers in and out, and you've got a rule about adding integrals, and you can combine those together to get a rule about subtracting integrals. Everything's got the same limits. There you go. Yeah. Yeah, so other things work like this as well. This is telling you that integration is linear. You can do the same thing for, I suppose, a rule about what happens when you differentiate polynomials. That's something else we've talked about today. You know that differentiating a polynomial, completely different style of maths, but differentiating a polynomial, if the polynomial is multiplied by a constant, well, a constant's you could bring the constant out if you like, it'll be there in your answer. 5 times the polynomial, well, the derivative is going to be 5 times as big. Put the 5 out the front if you like. So you can do that same trick, moving a number in and out of, in this case, differentiation. And maybe you know that the derivative of the sum of two polynomials is the sum of the derivatives. You could stick those together as well. As a result, the derivative of the difference of two polynomials is, as a result, the derivative of the difference. And the proof looks exactly the same. One of the nice things about maths, you get to reuse a proof as well as reusing some maths content. The proof looks exactly the same, except with differentiation signs instead of integration signs, using the same fundamental rules that happen to apply both to integration and differentiation. I'm smiling a lot because, well, obviously integration and differentiation are complete opposites, but in some senses they do some of the same things. They're both linear. Not like a straight line. Not all polynomials are straight lines, but both those operations are linear. Is Ginger Biscuit an undergraduate? So there's a question in chat. Ginger Biscuit, you can let us know, I suppose, but you don't have to. Slightly anonymous people. Somebody else in chat says, just like sigma notation for sums, they are also linear, so you can do similar things with those. Good, right, okay, I'm having fun. Yeah, so difference of two integrals is the integral of the difference, which maybe gives you different ways to think about this. So this could be the area under f of x, and this could be the area under g of x. And then the difference would be the area left over that's between f and g of x, which, and this rule says you could just integrate the difference between f and g. And you get the same thing. Algebra for integration. Isn't it nice that I haven't had to say what the functions are? Whatever, there you go. At some point there I started talking about areas. At that point I am assuming that the integrals are always integrating a positive quantity, because otherwise I run into that problem that we talked about where integrating a negative quantity gives you a negative number, but the area is supposed to be positive. So if you're talking about an area, you're supposed to get a positive number. Good, right. Okay, Ginger Biscuits, not an undergrad. Right, good, okay. I was doing this question and I think I've got bored. Sorry, question, but it wants me to do some integration. And then there's this second half of the question, which is very algebraic. It starts putting in this line, y equals c as well. And it asks for intersection points, which is an algebra question. It asks for me to do some different integration to talk about where to put this horizontal line to split a particular area in half. And I suppose my plan there is to integrate to find one of the areas and set it equal to half the original area, rather than integrating to find each of them. It says equal areas, so maybe something I might consider is equal areas, calculate both and set them equal to each other. That's one thing I could do. But because in a previous part we've already calculated, I haven't bothered, but we've already supposed to have calculated the total area. It's 1/6, so I might just calculate one of them and set it equal to 1/12, because I know that if they're equal, they're each half of the thing I've already calculated. I think I'd prefer to do that, because two horrible expressions that are hard work, don't really want to work them out. One expression equal to just 1/12, yes please, that sounds nicer as an equation. Good, okay. Hence find c, should we talk about that at the end? There's an equation down there, 4c cubed minus 6c squared plus 1 equals 0. Solve. Oh my goodness. So it's a cubic, so we probably need to just guess a root, guess a number that works. Does 0 work? No. Does 1 work? No. What would it need to be? Somewhere in between then. So what's between 0 and 1? My next guess is going to be correct, because my next guess is 1/2. I said that really confidently, like I knew it was going to work. And now I've thought for ages, which has ruined the illusion. Yeah, 1/2 works. How long would I spend on a question like this? So back in 2017, when this was a question, I think I would have spent about 25 minutes on this in the MAT, because of how the timings worked back then for MAT questions. I probably still would spend about 25 minutes on each long question. Let me just quickly do some maths. So there's a question in chat about how long to spend on different questions. You have 2.5 hours for the MAT. You have 150 minutes, and you would like to get 100 marks, of course. So that gives you a kind of rough estimate that maybe it's 1.5 minutes per mark. So when you see a 15-mark question, which is what the long questions are worth, the long questions at the end are worth 15 marks, you might think that you're going to spend about 25-ish, 22.5 minutes. Of course, the long questions, because they reward you understanding something, that might not happen immediately, but you might do some work on a long question and then think about it and then have an idea that's worth quite a lot of marks because it lets you unlock more of the question. So on here, it's quite hard, this 2017 question we've just been looking at, it's quite hard to get started until you realise what these functions are that they're talking about, at which point you kind of suddenly get lots of marks for doing your sketches and thinking about things and getting on with the integration. So for the long questions, I would allow myself a bit more than that. When you're doing MAT this year, you can skip to the long questions. The Pearson sample test is now live on our website. You can register, by the way, I had it on screen at the start. You can register for the test and you can try a sample test. So on the MAT website, you can get through to a sample test. Kay says that the questions are nicer, but it's there so we can think about timings. Yes, K is correct. There's always the 0.11 is always involved in that last question. So I think maybe I'd spend more like 25 minutes, half an hour on each of the long questions. Maybe not that much. Who knows? They're 30% of the marks, but sort of more 30% of the marks, maybe 30% of the time, maybe something like that. I'd want to have at least a look at all of the multiple choice questions, and there are 25. So for me, that's a little bit of convincing myself to make a note and move on quite a bit through the multiple choice questions so that I don't spend too long thinking about a single multiple choice question. I might come back to a multiple choice question, but I don't want to spend all my time thinking about question 13 or something like that, when there could be a nice big pile of marks waiting for me in one of these long questions. Will there be more than one sample test or should I save it? Joe, right. So the sample test is not designed as a sort of mock. You could use it as a mock if you really wanted to. It's there as a demonstration of what the software looks like. What does it look like to be given these long questions on a screen? A sort of user experience thing. So it's not really designed as a mock. There's just one because we're not sort of trying to demonstrate the questions so much as the interface. The interface would be the same if we did another one. Personally, I wouldn't use it as a mock, I think. What would I do? I'm not sure I would do a mock. I think I would just do lots of questions. Yeah, not sure I would do a time test. You could do a time test if you want to. Up to you. Are the long questions from the new MAT format the same length as the old ones, or are they longer? They're supposed to be the same because they're still worth 15 marks. This sort of comparison doesn't quite, it sort of works, but they're worth 15 marks. Okay. We'll get sample papers when we register. No, we're just talking about sample test, which is on the web now. And you've seen it already, you told me about the questions. There's no other sample papers. People are asking about, let's get it on screen. Where can I put this on screen? Here we go. Right now I should put full screen stuff. I'm going to wrap up. Here's the MAT page, which you can get to from the MAT Livestream page, of course. It's the one with the coffee cup. It's got a link to this. Oh, it is tempting, isn't it, to just go down that rabbit hole of putting the stream on the stream. But it's also got this thing down here, a practice test is what we're calling it, for you to see what the Pearson View system looks like. Can I launch this live? Let's have a look. Oh, I can launch this live. Okay. There's a disclaimer at the start, some information. We're going. Calculators, start sample test. Let's go. And then you get a question, multiple choice questions. And there's also this navigator feature to jump to. It tracks which questions you've seen. To jump to the long questions at the end, 26 and 27, if you want to. I've opened this in a stupid small window, so I'm going to have to scroll quite a lot to read this question on the actual computers in the test center. The standardized screen size. Oops. Can I just stretch it? Oh, I can. Look, there we go. Okay, good. Okay. It's got a timer in the right corner. I think if you click on the timer, you can hide the timer if you don't want to see it. It's got this kind of page count, which is not entirely useful because it's quite a large number. You can flag things if you want to come back to them. You can jump. So once you flag something, you get a little flag icon to remind yourself you flagged it. Once you're done, you'll get to the end of the test. Right, it's warning me that I haven't done all my scrolling. For example, I haven't read all of that question over there. Cool, right. Practice test, so you can see the system. Do I think the average score of successful applicants is increasing? No. Because of the multiple choice formats? No. Or because of the quality of candidates? No, okay. Will we get scrap paper for working? You get whiteboard paper is what we're calling it, I think. Noteboard paper or something, which in some test centres is whiteboards, in some test centres it's laminated paper and a whiteboard pen for you to write on. It's reusable, so that the test centre can reuse them for other tests. It's not exactly like writing on paper, but it's not terrible. So yes, you can write on you can scribble down some notes for doing those questions. We don't get that from the test centre or from you, so I do need you to click on options on the multiple choice questions and to type your answers for the long questions. That's math. Do you have any math tips from students who got in? This will sound like a bit of a brag, but a lot of the students I talk to recommend the MAT Livestream as a thing as their maths tip. Possibly this is because whenever I've heard a student giving maths tips, I'm in the room. But possibly it's because quite a lot of our students used the MAT Livestream in some way while they were getting ready for the test. We managed to reach quite a lot of people, including quite a lot of Oxford students. There are other tests you can look at, or other sources of tricky problems. I quite like the STEP support program as a similar program that's getting people ready for a tricky test. Of course, the STEP exams have a wider syllabus. There are more things that you need to know, including the chain rule, which this year chat seems very keen on the chain rule. I think I'm saying every 15 minutes I have to remind people that you don't need the chain rule for maths. There we go. What is the lowest score to aim for? Right, okay. I'm going to look straight down the camera and say 100. You should aim for 100. You should aim for full marks. You should try and get every mark you can get. What's a benchmark for interview? Well, you can look at average scores if you like, but there you go. Can you install this software, this whiteboard stuff? Great news, this is browser-based. We are just in Google Chrome. You can get this on the web. I'm using the free version. I've been using the free version for about 5 years. But it is just a web browser if you want to have this kind of whiteboard stuff that I've got. I also use this for interviews if I want to show someone a bit of a question on a screen for scribbling on a board. This is the first time someone's shown interest in installing Miro. You should have it, it's a website. STEP support program. Yeah, let's have a look at that. I think it's at the step.maths.org. Let me check that though. Yeah, well, there it is. It rearranges to. Can you see up here? maths.org/step. Minus step. Brilliant. And I think if you search University of Cambridge STEP support program, it's really good. The MAT Livestream is strongly inspired by the structure of STEP support programs. We've gone past 7 o'clock, so I think this is now not directly MAT support, but just other recommendations and chats. A little bit of biography. Before I was at Oxford, I was a student at Cambridge, and I was involved in STEP support material over at Cambridge. They had a summer school back then, and then it became the STEP support program. And coming to Oxford, I knew that I wanted to do support around the maths admissions test, which has turned into the MAT Livestream. So I'm still a big fan of the STEP support program, including perhaps for us at this stage, foundation modules, which have some assignments for you to try with a warm-up, some STEP questions to do with hints and support, and some extra stuff to look at afterwards, a format that you might recognise from other worksheets that are available for you to try for other things. Maths.org sounds like the person invented maths made a website. Yeah, we're a bit jealous of the Maths.org play for Cambridge Maths, Millennium Maths Project. There is a story there. The Millennium Maths Project was very large in the year 2000, and you get the website Maths.org if you try in the year 2000 and you're doing a lot of maths online. I heard that people don't get offers if they got anything below a 7 at GCSE. Is that true? No. Where did you hear that? Who was telling you that? Who could possibly know something like that? Sometimes I think that, like, who would know that? Who would have access to all of the GCSE scores of all of the Oxford students? Or all of the applicants? I mean, other than me. Right. Oh dear, sorry. I sometimes get a bit grumpy with students. Once students have been admitted, they sometimes believe that they know everything about all applicants and what makes a strong application and what a good maths score is. And sometimes you need to sit students down and tell them they're individuals and not always representative of wider trends and admissions. Do we know exactly? Hey, that's a good question. Do we have to know exactly what's not in the syllabus? Sorry. Oh my goodness, sorry. I thought this was going to be, do you have to know exactly what's in the syllabus to use that? Which is yes. But the question actually says, do we have to know exactly what's not in the syllabus? And that's so much maths. There is so much stuff that's not in the syllabus. There are many, many things not in the syllabus. You're not expected to know all of the things you don't know. To remember not to use that if we have seen it before. You are actually allowed to use it if you think it's relevant. And if you're following the instructions in the question. Like if the question says you have to do it like this, then you have to do it like this. You are actually allowed to use other maths. So you're not required to forget other things that you know, and you're not required to be aware of all maths topics out there that you don't know. I'm sorry for laughing at your question, but it was, as I read it out, it turned out to be the opposite of the question I thought it was, which amused me. Thanks, Ginger Biscuit. That's exactly what I mean. Has it been 15 minutes already? I have German GCSE. How are they, or the equivalent of a GCSE? So we look at your past qualifications. They tell us some information about what happens when you do lots of exams, but we're much more interested in what happens when you do lots of maths. For most students, they've got some previous qualifications that are in various things, and it's often the case that students have maybe a GCSE that they didn't like doing or equivalent, which might manifest itself as something underneath something below a 7 in some subject. Now, if that's maths, then something's gone pretty wrong there, and there might be a reason why something's gone wrong for maths. So the question about that doesn't admit anyone below a 7. If your GCSE maths is below a 7, it's very unlikely that you'd be making an offer, because it's very unlikely that you'd apply. It's very unlikely you'd be doing maths and further maths at A level, all of these things, unless there's something else going on, in which case there are ways you can tell us through your application. Do we need to type workings in the new format? Just explanations. We've designed these long questions. You'll see if you look at the 2024 questions, we've designed these questions so that you can answer them using words and a standard keyboard and basic symbols that are on a standard keyboard. You're not expected to type up detailed workings. Could you get 100 on the mat? I don't know. You've seen me make a lot of mistakes already. I'm not certain, but no, I'm going to back myself. I could definitely get 100 on the mat any day. Yikes! That sounded terrible, didn't it? It sounded really awful. What would I say a competitive score is now? You should aim for 100. And then if you don't get 100, well, that's probably still going to be okay. We'll see. You don't have to get 100. Maybe if I say this too much, then it stops being motivational and starts sounding really, oh dear. It's supposed to be motivational. When I look down the camera and tell you, you're going to try to get 100, that's supposed to be a motivational thing. Right. Callie, by the way, if you're watching, we've gone past 7 o'clock. You can call it a day. I will do the chat for a minute here. Tips for IB applicants. with maths high level analysis approaches. That sounds good. That's accepted. Carry on. This IB student, you're doing maths at high level. That's as much as we can ask for. Carry on. We think that's okay. Nice to see you too. If you didn't do GCSE further maths, oh come on. Most people don't do GCSE further maths because most people don't get the chance to do GCSE further maths. I didn't do GCSE further. Did I do GCSE further maths? Did I do some sort of freestanding maths qualification? I might have. Goodness me. Some people get the options to do extra things in school, but not everyone does. Are the longer questions marked by a computer or a human? Definitely a human. Oh goodness, they're text, they're writing. Humans, yeah, computers can't read text. Do the best you can, yes. Is the Tamura good prep? Yeah, you could look at Tamura as well. It's got a very similar syllabus and it's also got multiple choice questions. So you could look at TMUA as well. Oxford doesn't use it for admissions, but you're welcome to practice by using Tamura questions. 5 in GCSE maths would be a real... But A-star predicts in further maths. And I have questions, right? Like, why did your school let you do further maths? Because lots of schools won't let you do further maths. And then I see, haha, I think not really. Right, okay. Good stuff. Should we do the 4 A-stars one? Somebody else has heard. Here it is, yes, okay. I heard if you aren't predicted 4 A-stars A-level, you won't get an offer. That's not true either. Some of our students are doing 3 A-levels, and that's fine with us. And some of them, you know, that 3rd A-level, we don't need them to be predicted an A-star. It's nice if they are. And often students... You know, their teachers just predict them loads of A-stars and everything. Doesn't always mean they get the A-stars. Let's put some question marks on this because I worry that someone's going to take a screenshot or something. And this is they're roughly equals to, right? That's a suggestion. If you get marks at an equal rate, which is quite a weird hypothesis. Right, okay. Should you submit your percentage if you got almost perfect score in maths GCSE? There's no box for you to submit it. You could tell us about it in your personal statement. You've probably got other stuff you want to tell us about in your personal statement. Up to you. We're not going to do anything with the number. I'm sorry because we don't have a box for it, so we don't get it for most people. If you want to, this is someone asking about percentage for GCSE maths. And the I heard that is getting a bit out of hand. It's been a very long day of the open day. Here we go. Well, no, because there's serious questions mixed in there as well, right? Like, if I don't have GCSE when I'm 16, yeah, this is fine. You don't need to have GCSEs. We're looking for school leaving qualifications, and we accept lots of different school leaving qualifications from around the world. Not all of them, but quite a few from different countries. Have a look on our international qualifications page if you want to see whether what you're doing in what you're doing as a school leaving qualification. We don't need you to have GCSEs or equivalent. Joe, the standard conditional offer is 3 A-levels. We would almost always make standard offer of A-star, A-star, A to someone doing 4 A-levels. I would almost always say A-star in maths, A-star in further maths, A in either of your other subjects would be the standard text that we use. Do you need a grade 9 in GCSE? Wouldn't hurt if you got a grade 9 in GCSE maths. That's the top grade. We have also admitted people with a grade 8 in GCSE maths, and then not so much with a grade 7 in GCSE maths. But I think that makes sense, right? Loads of people get 8s and 9s in GCSE maths. And if you get 7, some schools won't let you do further maths. So self-selecting pool, really, in some sense. Do admissions like to hear about rankings in school for AS levels, mocks, or SMC kangaroo? I don't know. So your ranking in school tells me a tiny bit, I suppose, but not really. We're not collecting this information for candidates systematically. So your referee might say something like, "This is the best student, so well on a kangaroo, better than everyone else in the school." But equally, they might just not say that. And we're not going to follow up to find out if you did a kangaroo. We're not going to go and email people and start trying to work out, 3rd best in the school on that day. Ooh, interesting. We're just going to look at the maths. We've got maths instead. We don't need to go and dig into your previous ranked performance because we've got our own maths test, which is very good. I've heard you're not going to get in if you go to a state-run school. Yeah, you've got to hit a nerve now, because Oxford is perhaps more state school than people think, and Oxford Mathematics is one of the courses that is the highest percentage state school. There's something about maths which seems more equitable across the grade distribution and across Oxford admissions than other subjects. You hit a nerve. That's a thing that people think we're terrible at, that actually we're not that terrible at. What are these questions? Yeah, I know, it's sort of devolving, isn't it? I don't know if I'm encouraging it or making it worse. When I read out the question, I ruined it. And now we're getting the ruined version of the questions. Obviously, the criticism of grade 10, the criticism of the new GCSE scores was that clearly at some point they're going to do grade 10, and they haven't done it yet. I'd quite like it if they were a grade 10, I think, because, then, I think that'd be quite fun. I don't know why I like that more than 9, but I kind of like the possibility of an 11. It's sort of like it if your GCSEs go to 11. I think that would just be quite fun. Going to 9, far enough. I guess they're single digits, which is quite good for some horrendous ways of processing data, is to take them as single digits. I'm now thinking any chat message that starts, I heard that, I'm now taking with an element of, this might end, haha. What does it say? I heard that if you're an international student, you are more likely to get in. I don't think that's necessarily true. International applicants are often a bit different from home applicants in several ways, because for international students, if you're proposing to go overseas and study at Oxford, change country, pay overseas fees, there are several other things going on there, which we think affects the pool of people we get applying. So it's not really apples and oranges, and we don't have a... It's not really apples and oranges? That's not a phrase. That's not a thing that people say. Whatever. We don't have a quota of these things, people from home or overseas. We can just take the students with the best potential to do well on our course. I had the opposite. Oh, is this called rage bait? I've spent the whole day doing open day where I just answer questions that people come to me with. I am in question mode where people ask me all sorts of things. What's been my favourite? Somebody asked me whether there was proof in MAT or in the Oxford course because they don't like proof. Okay, I go to private school and I've been told to apply to a college. Oh, good luck with this. Oh dear, good luck. Oh dear. Oh, that question got worse the more of it that I read. Right, hello anonymous at a private school. Have been told to apply to a college with a high private school proportion. Okay, as I'm more likely to get in, so that is the confusing previous admissions decisions with your personal probability of success, which is a distinction that I care about quite a lot. But anyway, here's the rub. Part of my job is to make sure that people who apply have equal chance of getting into Oxford overall, no matter which college they apply to. Which means that if you apply and you're not very good, not you personally, let's talk about someone else hypothetically. If somebody else applies and they're not very good, then their college is not required to take them. The college can take strong candidates who apply to other colleges. So your kind of college choice doesn't affect the probability that you get in overall, because we have so much cross comparison and so many opportunities for colleges to say, no, not this one, we'll take someone from a different college. So your college choice isn't really a way to game it. And then if you think that different colleges have different demographic preferences or different, oh my goodness, right, okay, standardized admissions criteria. I'm an admissions coordinator, it's me. Right, do you think a new format is harder? No, actually, lots of people told me that switching to multiple choice questions, wouldn't that just make it really easy? Right, hard multiple choice questions is the thing we've been doing. Is New College where Harry Potter? Oh, several colleges have claims to tiny bits of Harry Potter being filmed there. Christchurch is the obvious one. They've got a bit of staircase. I sort of wonder how many more years it will be where people, will those films live forever? Or is it Maybe they will. Maybe people will always care. The staircase where Harry Potter once stood. Do you have an August pool like Cambridge? We have better than that. We have constant pool. That sounds like a party. A constant pool. All of the students are in a shared database electronically. All of the colleges can see all of the students. We do have something called open offers, where some of the offers are, okay, fine, with a college, but the text of the offer says we might change your college, or something like that. When results come out, we do a little bit of shuffling around so that if we've lost some people, we can shuffle around to fill gaps. We notify people in their offer that they've got an open offer, and their college will be finalised in August. And quite often they end up at the college that it names one as kind of a default. If nothing changes, then you'll be at this college. And quite often that happens, half the time maybe, something like that. And there's some shuffling. So we have, I guess you could call that a pool, but that's not really a pool for missed candidates or anything like that. That's kind of a little bit of shuffling for people who've made their offers. Cambridge is different because Cambridge have quite a lot of stuff going on in August when they get step results in August. Oxford, we're already basically done at that point. Enjoying our constant pool, a new party I've invented, because we've done the maths already and we've made our offers, and almost everyone who gets an offer from Oxford Maths starts the course. So in August, next month, right? August results day, I don't have that much to do because we have these ones that are open offers, which might move around between colleges, but I'm not expecting to see that many people miss their grades and need to go through any kind of like pooling thing. But there you go. Is Oxford closer to London than Cambridge? That's just geography. We should look that up. That's a good question. Is Oxford closer to London? What is it, about an hour on the train for each of them? It's close. It's maybe so close it makes no difference. Advice on taking 5 A-levels. I don't know. I haven't done that. It sounds like hard. It sounds hard. Advice for 5 A-levels. Have a really good study plan. Work out which bits of your day you're going to do what. If you've got any free periods, work out exactly what you're going to do, because you're going to have a lot of deadlines for homework and things like that. Maybe look at your evenings and weekends. It's horrible, but maybe start to plan out what you're going to do at various points in there. Give yourself breaks, give yourself days off. My goodness. Oh, that's much better. I like that one. Oh, I wish I'd been brave enough to just say that. Advice for 5 A-levels, don't. Don't clip that. Right, who's the least humble, worst mathematician? The questions are getting more and more wild. This is great. The effect here is that I've missed a train and I'm waiting for the next train. So yeah, where's London, right? London is a set. So is the closest point in London to Oxford closer than the closest point in London to Cambridge? Oh, brilliant interpretation of the question. Does it matter if I participate in kangaroos or other maths competitions down here? I'm not going to say it doesn't matter, because some people find these things really useful. I liked maths competitions a bit when I was a teenager, quite competitive. I liked them as long as I did well at them, and then I got through to some competitions that I did not do well at. I was less keen on those. What a terrible teenager. That was me. So they're sort of, I think, quite important for some people. Some people are going to talk about these in their personal statements, and some people are not going to talk about them. That's fine. If you don't really like kangaroos, then other stuff is available. Right. Okay. Have I met a famous mathematician? I have introduced Andrew Wiles as Andrew Wiles was doing a maths talk, and I did, I'm not going to say warm-up act, but I did a bit of stuff at the front to talk about the building, which is such a cool intro, because then you can say, and of course the building is named after Andrew Wiles. And now to tell you more about some maths, here is Andrew Wiles. It was great. Yes. Right, good. Okay, 11:54. I think advice is perhaps bedtime. You don't have to listen to me. Stay up and do maths, hooray. Right, okay. Are we calling it there? I think we're calling it there. Thank you so much, Callie, for hanging around and moderating chat. Thank you to everyone else for joining in. The questions are getting weirder and weirder as we go. We're going to call it there, I think. Right. I'm really sorry to anybody who stuck around to 25 minutes there, just in case I said any more maths. I hope at least you were watching it on double speed, so that it was only 12 and a half minutes of nonsense. But nice to get to know people in chat. Nice to answer some questions. There we go. Good. There is some chance that I interview people. I interview quite a lot of people. You shouldn't apply to a college based on interviewers, because just because I'm smiling and friendly in the MAT livestream, I'm still going to ask tricky questions at interview. Right, good. Take care, Mary. Take care, Anonymous. What does he do now after Fermat's theorem? I think maybe Langland's program, he gave a talk about some of that stuff. It would be really cool, I think, if he proved another massive thing in maths, but he really, really doesn't need to, because he's proved Fermat's last theorem. And if that's not enough, then I don't know what is. Can I watch the live stream on double speed? I wish. Do you think I can record it at double speed? No, I don't think that works. Right, see you in... Is it that many? See you in 165 and a half hours for another episode of the Oxford MAT Livestream. Next week, I think it might be logarithms. Is it time for logarithms? I love logarithms. I've been showing people at the Open this logarithm question with base x squared plus 2. Is that next week? That might be next week. So I'll see you then. If you want to get ahead, you could look at the worksheet. Link on screen, link in the YouTube description. Search for MAT Livestream to get the worksheets. You can also get the solutions there, so you could cut out the middleman and just go for the maths if you like. First hour no chat, then play it at double speed. Interesting idea. I can do the whole thing with no chat, put it on YouTube, and then everyone can do it double speed. Right, good. Yes, drink some water. Right, good. Thank you, chat. See you next week.